Ocean wildlife safety is at stake. Our oceans are being polluted with these endocrine disrupting compounds. Endocrine disruptors are chemicals that mimic the action of natural hormones in the body. They bind to hormone receptors, blocking the hormone from its daily functions. As a result, endocrine disruptors result in adverse developmental, reproductive, neurological, and immune effects in both humans and wildlife. A wide range of substances, both natural and man-made, are classified as endocrine disruptors, including pharmaceuticals. Endocrine disruptors may be found in many everyday products, including plastic bottles, metal food cans, detergents, flame retardants, food, toy, cosmetics, and pesticides. To see their impact on aquatic organisms, let's take a deep dive into some of the research happening at McMaster University. Capitella tellida is a marine worm native to the east and west coast of North America. It is not known if invertebrates like Capitella tellida create sex hormones like estradiol. However, it is known that this worm has estrogen receptors. As a result, endocrine disruptors could bind to the estrogen receptors in this organism and cause negative consequences. However, estradiol signaling is not well studied in invertebrates, so the effects of these pollutants on this worm is not known. Andrea Morello, a PhD student in the Wilson Talks lab at McMaster University, is investigating this question. Let's talk to Andrea about her project.
Hello there, everybody. When I was an undergrad, I was going through a major crisis. I thought that because I liked science, I had to go to medical school. My family is from Honduras, where there aren't that many scientists, so I didn't know that that was an option for me. I joined a lab because I thought that's what you have to do if you wanted to go to medical school, but I ended up falling in love with research, so I ultimately decided to go to grad school. I decided to go to McMaster for my PhD after I met my supervisor, Dr. Wilson. I was really interested in the project she wanted me to do, and it was completely new to me, so I decided to take it on. My research focuses on the estradiol signaling pathway in Capitella tellida. We know that Capitella tellida has estrogen receptors, so I'm trying to figure out what happens when estradiol, a form of estrogen, binds to those receptors. We know a lot about estradiol signaling pathway in vertebrates, but we know nothing about them in invertebrates. This has become a pressing problem because we have no idea how endocrine disrupting compounds affect these organisms. These compounds bind to estrogen receptors just like estradiol, but if we don't know the effects that happen when estradiol binds to these receptors, we won't know what happens when endocrine disruptors bind to them either. It's important to understand the basic biology of these organisms if we want to know how they're affected by pollution. Using a lab technique called RNA in situ hybridization, I can use a fluorescent probe to see exactly where the estrogen receptor gene is being expressed. This might provide clues about the role of estrogen receptors. I'm also exposing the worms to an ER agonist, a compound that binds to estrogen receptors. These mimic the action of endocrine disrupting compounds so we can understand their effects.
Through Andrea's research, we can gain a deeper understanding of the effects of pollution in our oceans and raise awareness of how human actions impact wildlife.